So we are here today to talk about some amazing new products on GCP platforms. That's Vertex AI, and I brought to you only a slice of it, pipelines, and let's see how we can automate the MLOps, because after DevOps now there is MLOps. So let's see what's in short about me for those who see me first time. I'm Marton, I'm based in Târgu Mureș, Romania. I'm a backend developer at a local company, and we develop a lot of scalable software, and nowadays all our applications have a little part of machine learning, and some of the projects have a full machine learning pipeline that we deploy multiple times a day as little bit pieces of some components they are changing. I answer a lot of questions on Stack Overflow. You can find me on Stack Overflow with the Pentium 10 username, and I recommend you my article session on the Medium wall, so you go ahead and check it out. I blog about interesting GCP products. So our agenda today includes Vertex AI, which is a managed platform on the GCP platform in order to run anything that's machine learning, to have your data sets, models, and everything to train, eval, and even deploying the model for serving. We will see how pipelines help you to actually do this in steps and connect these steps, and then eventually we will see how to adapt to changes of data, because once you have a pipeline you need to trigger it somehow, and by triggering it automatically new models will get built to your production pipeline. You can check out the polls section. I put there a question that I'm interested to hear how frequently are you deploying to production machine learning models. So please check out the polls tab and interactively answer some of the questions from there. So let's see, what is MLOps? It's a DevOps principle to machine learning system. So it's interesting to hear that nowadays we no longer just assemble and do packaging of code and deploying APIs, deploying websites or any other components. We are also deploying machine learning complete systems. And nowadays you can find out more and more topics about just MLOps. If we look at the elements of the machine learning system, we may have there lots of elements like data or verification, even automation at some sort, but we don't know yet what could be that. There is testing, debugging, there is model analysis, metadata management, and serving infrastructure, where you host your models, how it's going to serve, and all these need to be actually with infrastructure management, need to be deployed, need to be handled. That's why we will go to talk about pipelines, how they connect all these elements in order to run for you automatically, like it was an API. So MLOps, in other words, and to this presentation, is about continuous delivery and automation pipelines for machine learning system. So let's go deep onto this process. I brought to you 3 levels of MLOps as the books define, and that is, first of all, the manual process, which a lot of organizations still have, and only when they are certain that their operation, their machine learning model is enough matured, then they manually deploy it to production. But then there is the machine learning pipeline automation, and we will see the CI/CD pipeline automation. One is the deploying the model and automatically training it and evaluating, and the level 2 is actually deploying the specification for the pipeline itself that will trigger the level 1 process. So with a GitHub commit or with a data change in your data set, you could trigger the pipeline automation. If we want to further deploy this, there are definitions for it, but manual process, I don't want to explain it because you know it what it is. The pipeline automation, it means that you have a continuous training of the model by automating the pipeline. So you frequently get started a new pipeline to get a new training of the model out of it. New pipelines mostly based on new data. So essentially organizations that run these automations, they have new data coming in and they recreate the models as well. But then there is the CI/CD pipeline automation, and that's interactively trying out new machine learning algorithms and new modeling, where the experiments are orchestrated. So it means that the developers or some other system is actually tweaking your full pipeline, your parameters, your data sources, even some models, and the output of this stage is the source code of the machine learning pipeline. These are actually steps, and then are pushed to a source repository. And from there, the source, it actually becomes the output is the pipeline. We will see what this means much more in a diagram, because I created a DevOps style diagram in order to show you how to handle this. And we will go from the bottom to the top. So what you see here right now is that we have here, let's say, a prediction service, and the prediction service could be deployed as a manual process as well. But the manual process also could trigger a train model, and the model continuous delivery to actually sets a hosting, or the prediction service is getting an endpoint for that, and eventually there is a monitoring for that. If this is the, let's say that the manual process is the level 0 of automation, then there is the automated pipeline. The automated pipeline usually triggers based on the new data or your data set, and from here there is a continuous training. So when there is a new data, you get to train the model continuously gets delivered, the prediction service is in production, it gets monitored, and then after again a new data, you get another train model, another prediction service, a new revision gets deployed, and the monitoring as well. So essentially this is the level 1 of automation in the MLOps industry. And the third one is actually the one where the development or the experiment, the source code itself gets committed and pushed to a repository, and from there is a pipeline integration like CI/CD integration that packages the pipeline into the continuous delivery system, and the pipeline automatically is started based on this operation. So essentially, if we want to signal it, the manual process is as an individual island, then the level 1 automation is running the pipeline, and the level 2 automation is that all the developers can commit to your source code, and all the assembly and packaging will happen and will trigger your machine learning pipeline. As we go up with level 1, level 2, the monitoring is much more important, because, for example, a bad source code commit or a bad packaging information could cause you a wrong prediction service in the production. That's why there are pipelines to actually assemble this and test all the elements of it in order to have it a good model for it, even a better one. Let's see part 2. What is Vertex AI? Vertex AI is a managed machine learning platform to accelerate experiments and deploy AI models. Essentially, I would say, in other words, it's a hosting service for your machine learning models. You can also serve, like it has an HTTP endpoint to serve the models as well, and then you just need to actually call that API. It's managed, it's part of the Google Cloud Platform. It has a lot of underlying software and underlying components to it. So essentially, from data sets to training to modeling to have a prediction of it, to run experiments and integrate, for example, Jupyter notebooks or running deep learning environments, and anything that's a custom model that you can define your own container, or run the Python components. And all the AutoML, which is a managed service, and it's a no-code solution. So essentially here, someone in the AutoML phase, the model itself is being managed and being offered by the Vertex AI AutoML system. And you can actually use them as an APIs. Essentially, is a unified machine learning platform. So it's serverless, it has an operational model, and it has a programming model. The programming here is not a function as a service like people tend to think in the cloud agnostic way. Here, instead of function, we have model as a service oriented feature. And you have open SDKs to integrate with all the machine learning frameworks to deal with. So essentially, you can bring your own language, but the model itself is the one that you deploy to the system, and it's being served for you. Using pipelines throughout your machine learning workflow. Let's see, among all these, we will talk today about this little thing, pipelines, which orchestrates all the elements of the Vertex AI platform. And let's see in a nutshell why they are pipelines useful nowadays. So essentially to orchestrate all the steps as a process. So in the machine learning industry, you have a lot of small steps, but to connect them, you need to actually orchestrate them. So no longer handle all data gathering, model training, tuning, evaluation, deployment as a monolith. I've seen organizations often that each of these phase is actually handled as a monolith. Could have been different code bases, it could have been different teams. So data gathering, I understand it's a new team. Model training, tuning, evaluation could be also handled together or separated as well. But pipelines are useful to connect all these. Adopting machine learning for production models. We need a repeatable, verifiable, and automatic process for making any change to a production model. This sounds nice to the managers, and it's easy to work in a team because each member can actually focus on one thing, and the managers itself have a way and ensures that there is an automatic process for making any change to a production model. Essentially, develop steps independently is an item, and it scales out as you enable it to share your machine learning workflow with others. So think of themes, and you can run it and contribute code. It means that you enable to track the input and output from each step in a reproducible way. You can have a junior developer working on data gathering or data labeling, and you can have, I don't know, a middle engineer to work on one kind of machine learning initiatives. Then you could have just a general programmer to make it the serving endpoint of the model, and all these could put together by the pipeline itself. And now let me show you a basic pipeline definition. Here you have visually a pipeline, and I will spend time to actually explain what is on this screen. So this is done by Pierre Exposito, a fellow GDE. It's part of the Google Cloud ecosystem. You have this example on his GitHub pages, and you have it here, the URL, in order to see it, and it's called, it could be like a hello world example. Let's see in the diagram, you have a step of get the data that produces an artifact. This is actually an artifact, the data set. The data set is being used in the model itself, and the second step is actually training the model. The model itself creates a model, the output is a model, and then it goes to the eval step. The eval step uses another data set and a model to actually do the evaluation of it and produces two other artifacts. These two other artifacts are, let's say, scores or metrics table in order to evaluate your model based on the training or based on the evaluation data. So the first step again is to actually gather your data for the machine learning, create a training data set, create an evaluation data set. The training data set gets used in the training process, then it creates a model artifact. And the evaluation process, it produces some metrics, a score, variables, whatever we name them. In the code itself, there is a decorator. There is a route where the artifacts and other fixed systems will place their primary and temporary code. There is a name for the pipeline. And essentially, this is a very reduced example. You have the three operations: dataset operation. Here in the pipeline definition, that's the get data function. It's omitted the get data function. Then the train operation, in order to train, here you have the SGB model in order to run just an example. And here you have from the previous variable dataset up the output, which is a dataset, the training dataset. Actually, the training dataset, this is the artifact of it. Then you have the eval operation. The eval operation uses the test dataset, which is here, and it was created by the first step, dataset operation from here, dataset operation output, and the model itself, which is the model artifact. Then you compile this into a pipeline, and you get here a package path of a JSON file. Why is it important? And you should pay attention to this JSON file, because that JSON file is the one that is the pipeline, and you can create run from the job spec. It's called the job, and the pipeline is executed based on the JSON file. In a nutshell, you can have a GitHub repository to actually offer this JSON file or an API service. And if you put together the JSON file, I mean, you put together this small concept, triggering the pipeline is just calling the JSON file. Essentially, you get level up. You have an automation of your machine learning operations. You provide either the code that produces the JSON file or the JSON file itself. It's a very nice and easy way to automate things. Let's see an example. So we could run, for example, a get data, train model, and deploy the model phase. Let me show you that on the Vertex AI interface. The Vertex AI interface in the Google Cloud Platform, this is the welcome screen. You have here that it has menu points for data sets. You have the workbench, that's the Jupyter notebooks. You have the pipelines, the training, experiments, models, endpoints as well, where you host your models for HTTP serving. Essentially, in the workbench, I have a Jupyter notebook, but there are other managed and user-managed notebooks in order to have easy accessible to a Hello World example and to use it. You can use your own project VS Code as well in order to create these examples. In the Jupyter Lab, I created an example based on what I already show you, and here there is only an initialize phase, and what you need to observe that I'm using the Google Cloud Pipeline components. This is part of the library that's offering, so I don't need to actually define the under the hood pipeline elements. I just like to use this as the pipe variable as well. And then I have the decorator in order to recognize this as a pipeline as well. What you see here is that I have an image dataset create operation based on the source. I have it here, and I have managed image single label classification schema where it's offered by the Vertex AI, and it's not part of my talk. I'm just using the pipeline component and explaining to you. Then I have the training job here, which is an auto ML training job for the flowers classification job. And in the end, I have an endpoint, and the endpoint is like creating a HTTP service, but it's nothing attached to it. Then there is the model deployment, where to the endpoint I attach the model itself. It could be like an API serving a database table, but instead of the API serving a database table, this time the endpoint actually serves a model. This goes into the pipeline, and if I execute the pipeline, I see something like this. So I have an image create step. I have this is actually creating the data set. Then there is the training process. This creates the model. You see here the artifact. And there is the endpoint. This creates the endpoint. And the final step is actually deploying. So I deploy the model and I deploy the endpoint to it. And all these are individually handled. So right now, I've already run this for you because the training step is taking a lot of time in order to actually, as you know, machine learning training is running, for example, like for 6 minutes. But if I go back and I've changed here, so let's say replicas, I change here replica number and I run it again. Where is the run? Okay. And then let's go into here, refresh. And you should see a running pipeline. Okay. And if I access this new pipeline, what you see here is that the previous steps are reused. So they are cached, and actually only the last component where I've changed some parameters, like I'm deploying 2 replicas, is going to run and execute. It's very helpful, and it's indeed helpful for everyday use, because, for example, if you don't change the training only on the deploy, and you have you could have here conditionals and evaluation logic, and then you don't need to wait in order to retrain the model as well. If you have new data, that actually rebuilds the full model as well. Also, the endpoint is not recreated because that may exist. Also, in case there is an error, let me suggest one image. In case there is an error, it's identified exactly on which step is the error, and you can view the logs in order to actually figure out what was the error. Failed to create the echoes, minimum replicate count, must be something like, I think the numbers need to be different for there. Now, going back to my presentation and showing you the same slide for what I've just shown you in the interface. So you have this example here on the Google Cloud Platform under the Vertex AI samples, and essentially creates, trains, and deploys a model on an endpoint. And then you can serve that endpoint as it was a HTTP endpoint, and the prediction can be done. Good. If you want to go further, you may have a scalable operation, but you could have conditionals as well. If you have also the create training process, you could have an eval step in it. And the eval step decides, and this is actually a conditional way of running the pipeline, decides if the evals is reaching the target, the threshold that you set up. It could be like accuracy, it could be a score, it could be a better system, and only deploys to production if that score is happening. And this is what I love about this system, because it will let us to actually do complex examples and canary builds as well, because here you can have a lot more workflow and a lot more complex workflow to actually run your machine learning operations. It's developer friendly. It uses the Google Cloud GCP pipeline components, which support easy access to Vertex AI services. You can have your custom components, so you can. There is a syntax for that, how to bring your custom container, and a step that you bring is identified as a container, and it's being run on a separate container. Underlying to what people think, that this is no longer a Kubeflow pipeline, and you no longer need to define a Kubernetes cluster to actually do arbitrary training for all sorts of containers. You can share the component specification. The YAML or the JSON format allows the component to be put under version control, or used recipes from the internet, because if that's a syntax or that's a recipe, you can download it and use it as well. You can leverage step caching, as I already shown you, that previous steps are not and you can have metadata and lineage tracking on the interface. I didn't show you that inverse pipeline of darks and so on. Essentially, the pipeline connects all the data sets, training models, endpoints, prediction, and metadata as well, because the scoring and model is stored as a metadata to the platform as well. Now, the important part also of me is that you have a functional pipeline, but there is a trigger for that. And in order to build free automatically, we need to identify a trigger syntax or a trigger component for that. And the GCP platform offers a few ways to actually do it. I only mentioned 3 here. The scheduler way, it's an easy one. Every day at 9 o'clock or every hour, start the process and start the pipeline. Then there is the cloud build, detect changes on code base. So essentially a GitHub commit and a push could be engineered into the cloud build hook, and it builds the pipeline. And the pipeline either produces the JSON file, or you as a code have a GitHub repo only set for the pipeline and you update it. I found it much more easier to actually have a separate repo for the specs, and you maintain a separate service to actually write in that repo the specs, because it's under version control and you can roll back easily with that. You have a trigger for, and you can trigger the Vertex AI pipeline. And the newest one is the event arc. Event arc is a product. It's a GCP product. And it's an amazing product because it's an observer system. So detect changes on data. And event arc has like 200 sources to identify what to observe and on what to change. So essentially, you can react to events from cloud services. You can handle these events on cloud workflow, cloud functions, cloud run, reuse the pipeline from the GCS and trigger Vertex AI pipelines. So event arc is the Swiss knife observability system in the cloud. So whenever you have a code, and only just to use this event arc system, people tend to have certain events emitted also to the cloud, because the underlying infrastructure and how the GCP uses is there, and it's happening for you everything. I really love how event arc actually resolves a lot of problems when you have your data and your events, whatever. It could be developer events, it could be business logic events emitted to a certain Google Cloud platform, and from there, as a cloud event is being picked up, and then you can connect the dots with it. I also love cloud workflows. The cloud workflow is a separate product, and you can call any API on the internet. You can have cloud workflows to actually trigger an AWS job, or trigger an Azure, data refresh on some studio. And we love it also for the really long time of the workflow. So cloud workflow on GCP can run for up to 1 year, and you don't need to actually schedule or request quota upgrades. You just set it up and it runs for 1 year if you have a long workflow, like running something in the after 6 months, a reminder to an email campaign and so on. So cloud workflow is great for that. Conclusions: enhance developer experience. So build with the groundbreaking machine learning tools that power Google. Approachable from the non-developer perspective. You have the AutoML, you have the managed models, and you have the training process. As a, let's say, black box environment is offered to you, but you can bring your own custom container as well. So it's not through black box model, you can bring your own custom container as well. Is the life of a data scientist and machine learning, because it has a feature store, which could have a person in your organization where it defines the features and it handles the data sets, and another person who signals and tracks and runs the endpoints as well. End-to-end integration for data and AI will build pipelines that outperform and solve complex machine learning tasks. So when you run in production a lot of machine learning, then you can easily run the build pipeline on the Vertex AI system. GitOps style continuous delivery with cloud build, that's expected, And I didn't explain too much about what these experiments are, but there is an experiment in the Vertex AI which offers the tensor board, and it offers explainable AI for some models. And if your model is compatible with the explainable AI system, go check it out, because it actually tells you under the hood information where the model has some edge cases, and I would say in a simple way it provides you a sort of histogram view of your complex model, and it lets you to actually pinpoint some kind of elements of your model in order to make it better, because you need to find out, to understand where your model lacks and to bring it some change to it. So essentially this concludes my talk for you today. Hopefully you enjoyed seeing what is the capabilities of Vertex AI and how you can run MLOps using pipelines, and that's automatically reacting to data changes using event arc, but also the scheduler or cloud build for code changes and so on. If there are any questions, I'm happy to actually answer it. You can trigger on Twitter as well. Marton Kodok is the Twitter, and the slides are available on SlideShare as well. See you next time.